Good afternoon, everyone. Is there any class going on? So only few students join yet.
No, sir.
Is the screen visible?
Yes, sir.
Okay. What we covered in last class? Up to how much we finished?
BCD addition and subtraction.
BCD addition, subtraction. Okay. So next we'll start with the other kind of binary codes. In BCD, basically we discussed about the 8421 code or natural BCD code. Apart from this, so many other BCD codes are there. In our syllabus, next we'll study about the XS3 code. So using this code also, as it is a BCD code, so we can represent from 0 to 9. Okay. So here what to do? To represent 0 to 9, first of all, we need to write the 8421 code. In that, if we'll add 3 to it, as the name suggests XS3, so extra 3 needs to be added. 3 means 0011. So whatever the number will get, that number or that combination will represent the decimal number. So 0 in BCD is how much? Natural BCD. It is 40. If I'll add 3 to it, what will happen? 1 plus 0 is how much? 1 plus 0. How much 1 plus 0 is? Am I audible?
Yes, sir. Yes, sir.
How much will be 1 plus 0?
One.
1.
1. 1 plus 0, 1. 0 plus 0, 0. 0 plus 0, 0. So what will happen? 0 will be represented with double 0, double 1 here. You can see. So in case of XS3, 0 will be presented with double 0, double 1. Now let us see, suppose for 4. What is 4 in BCD? Natural BCD? It is 0, 1, double 0. If we'll add 3 to it, what will happen? What will be the result? 1 plus 0, 1. 1 plus 0, 1. 1 plus 0, 1. 0 plus 0, 0. So this 0, triple 1 will be represented for 4. Okay. So you can see that. So in this way, we can represent from 0 to 9 using this combination. And each combination will represent the decimal digit from 0 to 9. Okay. So here again you are using 4 bits. If you are using 4 bits, how many possible combinations are there? If you are using 4 bits, how many possible combinations will be there? कितना possible combination होगा using 4 bits? If we have 4 bits, 1, 2, 3, 4, how many combination can be possible? Am I audible?
16.
16 possible combinations, out of which how many we are using? We are using 1, 2, 3,
10.
4, 5, 6, 7, 8, 9, 10 because we are representing from 0 to 9. So 10 are used. So 6 are unused. So which 6 are unused? Which 6 combinations are unused? So basically 0, 1, 2, then 13, 14, 15. These 6 combinations are invalid. These 6 combinations are not used in XS3 code. Okay. So it has some significance. Later on we'll see what is the unique feature of this code. Okay. So XS3, by adding 3 to the BCD code, natural BCD code, we can get the XS3. Next. Next is gray code. Gray code is not a BCD code. This is a binary code. Okay. So any number we can represent with the help of this gray code. So before
Sir, can you show the last slide one, please? Sorry, sir.
this one.
Yes, sir. Thank you, sir.
Now, what happens? Now, suppose I will represent 0 using 4 number of bit. Then what will be 0? How I can represent 0 using 4 bits?
0000.
4 zeros. Okay. After 0, what we used to get? After 0, what comes? 1 comes. So for 1, if we represent using 4 bits, what can we write? We can write 1 as 0001. After 1 in decimal number, what comes? 2 comes. What is 2? 2 is 0010. After 2, 3 comes. 0011. After 3, 4 comes. 0100. After 4, 5 comes. 0101. After 5, 6 comes. Okay. After 6, 7 comes. After 7, 8 comes. Okay. So let me stop here. We can go, okay, we can go up to 15. Let me stop here. Now, what is happening here? You observe here. After 0, I am getting 1 in decimal. Similarly, at that time, if you see this binary number, it is 40, but it is 30 and 1. So, how many bits are changing here? When we are going from 0 to 1, how many bits are changing? कितना bit change हुआ है यहाँ पे? Is it changed? This 00 not changed. Is this change? Not changed. Is this change? Not changed. What about this? This changes. So in how many position your bit changes? Only in one bit position it is changing. Next, you check for the next combination. After 1 I am getting 2. So if you compare this 1 and 2, in how many position it is changing? In 2 bits it is changing. Here to here and here to here. Okay. Similarly, you observe 3 to 4. This 2. In how many position it is changing? 3 position it is changing. Okay. Similarly, check this last 2. In how many position it is changing? 4 bit. In 4 position, in the all bit positions, your values are changing. Okay. So what happens, depending upon your requirement, here in decimal number we are going 1 up. It is a kind of sequential. Now its corresponding binary code, what is happening? Maybe 1 bit is changing, or 2 bit is changing, or 3 bit or 4 bit. So it is not uniform. Okay. So what happens when actually we design a circuit? If your number of bit changes for more times, then what happens? Unnecessary your power will get wastage because you require some gates to change that. Unless this is called as switching. You are changing from 0 to 1 or 1 to 0. So if unnecessary switching will takes place, unnecessarily your power will get wasted. Unnecessarily your power will get wasted. So how to stop that? To solve this issue, we need to go for the gray code. So in gray code concept will be using gray code, only one bit will change. It will not change for different. It will only change for the one bit position. That is the requirement of a code which will be satisfied using the gray code. Is it clear? What is the reason behind gray code? Is this point clear? Why we'll go for gray?
Sir, can you explain again?
Like we see here, we are going from 0 to 1, then 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8. But at the same time, in its corresponding code, what is happening? it should change with only one bit. But in reality, what is happening? Here it is
Multiple
changing one
bits.
bit. Here 2 bits, 3 bits, 4 bits. Okay. So if multiple bit changes, what happens? This is called as switching. So because of switching, what happens? More switching means there will be so many problems. First of all, your power will be getting wasted. Then there is chances of noise will be getting added. So the chances of misrepresentation will be there. So many problems will be there. So to solve that issue, we want for each consecutive digits only one bit should change. So if we'll go from here to here, one bit should change. Here to here, one bit should change. Here to here, one. For all, one bit should change. We want that. So that is possible with the help of gray code. That is possible with the help of gray code. Okay. So
Yes, yes.
next we'll see how to convert binary code into a gray code. So बताओ कोई भी एक 4 digit or 5 digit number, any 4 digit 5 digit number, any 4 digit number, example binary number, अरे कोई भी एग्जांपल दो एक 4 bit नंबर.
1101.
1101. Okay, this is the binary number. Now we want to convert it into a gray code. Okay, so what to do? To do that, first of all, what is the name of this bit? What is the name of this bit? इसको क्या कहते हैं? MSB. So whatever is written in MSB, first of all you need to copy it. You need to copy it. Okay. Then what to do? Then we need to check these 2 bits. So these 2 bits are same or different? They are equal or they are same?
Same.
If they will be same, then corresponding answer will be 0. If both will be different, then answer will be 1. Okay, so it is called as a XOR operation. So XOR will learn later on. So A XOR B is actually A bar B plus AB bar. Okay, so if both the inputs are same, then output will be 0. If both the inputs will be different, output will be 1. So basically we are performing that XOR operation. Next, we'll do XOR of these two. Both are same or different?
Different, sir.
So this will be 1. Then we'll do for this. Again, both are different. So this will be 1. So 1101's gray code is 1011. Okay. So now you understood how to convert binary code into gray code. Then next, let us do for 0 to 15. Do it for binary gray. Do it for 0 to 15. Do it yourself. Find out the corresponding gray codes. Okay. First के लिए क्या होगा? Again, you need to follow the same method. We'll copy it. 0. Then these two same or different?
Sir, same.
So 0. Then this two again same. 0. This two again same. 0. Next for this combination 0. This two same. zero, same, zero, different. This will be 1. Next, copied this 0, this 2, 0, 0, 1. How much?
One.
1. 1, 0.
One.
Next, 0, this 2, same. So, 0, this one, क्या होगा? Same or
One.
different? 1.
Okay.
This 2, same.
Zero.
Okay. Similarly, you can do it for others. So basically, point is to check how many bits are changing. So verify here to here. How many bits are changing? One bit. This bit. Next, this one bit. Here, this one bit. So each consecutive codes are changing only by one bit. They are not changing in more than one position. So they are changing only in one bit position. Okay. Is it clear? So similarly,
Yes, sir.
you can try for other numbers. Okay. Then next, just the opposite, how to convert gray code into binary code. Suppose, रुको एक एग्जांपल कर लेते हैं. Suppose find out for this 1010. What will be its gray code? This will be 1. Then XOR of these two, both are different. Then what I should write?
One.
1. Then this two, 0, 1, both are
One.
different. 1, 1, 0, both are
One.
different. 1. Okay. Now let us see what will be the, if gray code is 4, 1, what should be the binary code? 1, 0, 1, 0. So we'll verify that. Let us take that example. 4, 1. Okay. Now, if you want to convert this into a binary code, if you want to convert gray into binary, first of all, what will be this most significant bit? इसका वैल्यू क्या होना चाहिए?
Sir, one. One.
One only. Previous case also we copied it, so here also it needs to be copied because both has to be same. Because previously we see that we copied this, we copied this. Okay. Now, in previous case, what you used to do? You used to check this XOR horizontally. Now, what to do? Instead of horizontally, you need to check this diagonally. So both are 1 1. So what will be the result? Both are same. क्या होगा? 0. Then this two क्या होगा? 0 1. Both are different.
One.
1 1 1. Both are same. So 0. So 1 0 1 0. See 1 0 1 0. So in this way you can convert gray code into a binary code. Okay. So check this table. Go through this. If any doubt, try any 2 3 combinations. If any doubt, ask me.
So here, the self-complementing properties is very useful for the arithmetic subtraction operations because so if a code word is self-complementary, right, then you can perform the addition. Sorry, you can perform the subtraction with the help of the addition, right? Or with this, so you can perform the subtraction just using the
Is it clear?
right. That is the one of the that is the powerful property of the
Okay. Next.
we can call it self
So now our codes are finished. Now what we'll do, we'll see for the classification of codes. Okay. So how this codes can be classified? So codes can be classified in many ways. Okay. So we'll see one by one. First classification is weighted codes and non-weighted codes. Weighted and non-weighted. So in a weighted code, what will happen? Each position will represent with certain weight. Each position will have certain weight assigned to it. If each position will have certain weight assigned to it, it will be called as a weighted code. If no weights are assigned, that will be called as a non-weighted code. Okay. So as per this definition, can you tell 8421 code? What will be its? It will be weighted or non-weighted? 8421 code or natural BCD code, it will be weighted code or non-weighted code. Is it any
Correct.
weighted code? Because depending upon position, these weights are assigned. Similarly, other examples are 2 4 2 1, 8 4 minus 2 minus 2 1. So this corresponding positions will have certain amount of weight, like 2 4 2 1, 8 4 minus 2 minus 1. Then let us see for non-weighted code. What will be gray code? Gray code will be non-weighted or weighted? Okay, will be non-weighted. We are not assigning any weights to it. In gray code, we are not assigning any weights. How did we find out? We took the XOR operation. Okay. What about XS3? Weighted or unweighted? XS3 weighted or unweighted?
Non-weighted.
Non-weighted. Because how did we get XS3? By adding 3 to the BCD code. So BCD code is having weight. But XS3 what we did? In BCD we add 3 to it. Okay. So this is also non-weighted. So this kind of questions are possible. Short questions are possible. Explain weighted codes and why 8421 is XS, why gray code is non-weighted. So this kind of questions are possible. So next set of code is sequential code. So what happens in sequential code? Each succeeding code word, each succeeding code word is one binary number greater than the previous code. Okay. So for 0, suppose take an example of 8421 code. What happens? 0 is 40. If you'll add 1 to it, what will happen? You will get 0001, which is the code word for 1. If that is the case, it is called as a sequential code. Similarly, if you add 1 to it, what will happen? You will get 0010, which is the code word for 2. So each succeeding code is one binary number greater than the previous code, which is satisfied by 8421. What about XS3? Is it satisfying? What is 0 in XS3? What is 0 in XS3? 0 में क्या है? 0011. ठीक है, इसमें 1 ऐड करेंगे तो क्या होगा? 1 plus 1 sum 0 carry 1, 1 plus 1 sum 0 carry 1, 1 0. This is the code for 1 only. Okay, so XS3 is also a sequential code. 8421 is a sequential code. And XS3 is also sequential. Next is cyclic code.
Sir,
Yes.
sir,
Yes.
can you explain this one, sir? Not understood.
Whatever is the code, suppose take an example of this XS3. Okay. Suppose tell what is the code for 6 in XS3? 6 का कोड क्या होगा XS3 में? अरे 6 का कोड क्या होगा XS3 में? क्या होगा? Just write 6 0100. Sorry, 0110. Then you need to add 3 to it. 3 means what? 0011. If you add this, how much you'll get? 1 plus 0, 1. 1 plus 1, sum 0, carry 1. 1 plus 1 is sum 0, carry 1. So this much. So 6 is represented with 1001. Okay. If I'll add 1 to it, how much you'll get? 1 plus 1, sum 0, carry 1. So 1, 0, 1. And this 1010 is the code word for the 7. Okay. If this is the case, then it is called as a sequential. So whatever is the code, if you will add 1 to it, whatever code you are getting, that should be code for the one successive code. Okay. So each succeeding code should be one binary number greater than the previous one. That means if you subtract this two, then your result must be 1. This is the case in XS3 also. You can see in XS3. See here everywhere. If you add 1 to this, what will happen? You will get this 0 1 double 0. If you'll add 1 to this, you will get 0 1 0 1. If you'll add 1 to this, you will get this one. If you'll add 1 to this, you will get this one. So it is satisfying all the combinations. That's why this is called as a sequential code. Okay. It is also happening in XS3. It is also the case for the natural BCD. Is it clear now?
Yes.
Okay. So what about gray code? Is it sequential? Gray code. Is it sequential? Check this and tell. Is it sequential? Gray code.
No, sir.
It is not possible. Okay. Because see here. If you add 0001 with 1, answer should be 0010. But what we are getting? We are getting 0011. So it is not sequential. Next, cyclic code. Cyclic code is what? One second.
Because the n least significant bit, right? N least significant bit, please listen carefully. The n least significant bit of a for 2 to the power of n through 2 to the power of n.
Cyclic code. Next is cyclic code. So in cyclic code, what happens? Each successive code word differs from the previous one only in one bit position. So for two consecutive code words, they should differ only in one bit position. If it can satisfy this condition, it will be called as a cyclic code. So where this thing happens, only example is gray code. In gray code only it is changing it by one bit position. Is it happening in other case? In XS3 is it happening? Verify. Is it changing by only one bit position?
Student, tell me what is the one bit binary number?
Here to here. How many bits are changing?
Binary number is 0 and 1.
कितना bit change हो रहा है यहाँ से यहाँ तक?
2, 3.
So that is the one bit binary
This changes,
number.
this changes, this changes 3. Next, this 2.
Gray number is also 0 and 1. 0 and 1 is also the
Here only
one bit
1 is changing.
Now,
Okay. Next, if you'll see, 2 are changing. So it is changing more by 1 bit, more than by 1 bit. So they are not the cyclic codes. Okay. Next one. Next one is called as reflective code. Okay. So to understand this definition is little bit tricky. So to understand this, let me go to the next slide. Now, basically, I have mentioned here gray codes of different bit, 1 bit, 2 bit, 3 bit, 4 bit. So it is also possible for other bits, 5 bit, 6 bit. So it is restricted up to this 4 bit. Okay. Now, it is in the gray code. You can verify. First of all, you can verify it is in the gray code. Okay. So each successive code word differs only by 1 bit position. Now, take this 4-bit case. Okay. In 4-bit case, this is most significant bit. So what I am doing, first of all, I am removing this most significant bit. So that one I am omitting. So if it is a 4-bit combination, if it is a 4-bit number, how many combinations are possible? 4-bit में how many combinations are possible?
16.
16.
So if I will divide by 2 to that, what will get? 8. So I have marked that. This is upper 8, this is lower 8. Now if you will observe what happens, it is 100. This is 100. This is the mirror image. Whatever it is coming here, this is also same. Whatever is written here, it is same. Whatever mentioned here, it is same. 010, 010, 011, 011, 001, 001, 000, 000. Okay. This is called as reflection. So because of that, it is called as a reflective code. Exactly same thing happens for other bit also. 3-bit, here also I am omitting the most significant bit. So 3-bit, so 8 possible combinations are there. Divide by 2 means 4. Okay, now you check it. 10, 10, 11, 11, 01, 01, 00, 00. Okay. So this kind of code is called as a reflective code. So again, This example is only the gray code. It is only satisfies this condition. Other codes are not reflected. In other case, it will not satisfy. You can check. Suppose x is 3.
That's why it is called the
Check it here. Is it satisfying?
in least significant
So it is not mentioned everything, but up to 7 you can see.
in least significant bit क्या होगा 40
Okay, you can clearly see this is not satisfying.
so this is the
Okay.
2-bit code.
So it is not
Right, so this is the
reflective.
2-bit gray code. Now this is the 2-bit
So
gray code.
both cyclic and reflective. Only example is this gray code.
In least significant bit
Next.
क्या होगा?
Sir, can you explain the cyclic code once? I lost my connection.
So that the
Here, if you remove your most significant bit, if you omit that, then depending upon number of bit divided by 2. So it is
Sir,
16.
I said about cyclic.
image of
Cyclic is only gray code. So each successive code word should differ only in one bit position. So it happens only for the gray code.
that is the in
They are differing only in one bit position. For other codes, it will not happen. If they differs only by one bit position, it will be called as a cyclic code.
so this is the bit
Clear?
Okay.
0
Yes, sir.
2 3
So reflective codes definition is this. So whatever I mentioned, same thing written in a statement.
these 2 bits
So reflective code is a code in which n least significant bit. Okay, because most significant bit is removed. So n
another property
least significant bit for code word वो क्या होता था 0 to 7 and 8 to 15. If you observe here 0 to 7, 8 to
Are you sharing the slides, sir?
the slide is already shared.
So it is not visual, sir.
Is it the case for others?
Yes, sir.
Review.
The screen share has stopped.
One second.
Only one bit has changed, yes, that's why it is also called the minimum distance code or the minimum changes, sorry. That is the minimum changes code.
Now is it visible?
Yes, sir.
Okay. So reflective code is a code in which n least significant bit for code word 2 to the power n through 2 to the power n plus 1 minus 1 are mirror image of 0 to 2 to the power n minus 1. So suppose 4 bit tha, 4 bits. So how many least significant bits are there? I removed most significant bit. So how many were remaining? 3 bits were remaining. Okay. So what happened? Your 0 to 2 to the power n minus 1. So 2 to the power 3 minus 1 is mirror image of 2 to the power 3 to 2 to the power 4 minus 1, which means 0 to 7 is mirror image of 8 to 15. So whatever we mentioned, same thing is mentioned in a statement. Okay. So example of this reflective code is gray code only. Okay. Next code. Next set of code or classification is called as self-complementing code. Self-complementing code. To understand this, let me copy that 1 second.
So a binary number that can be converted to the gray code, right? So in this way, suppose you have a n-bit binary number, right? You have a n-bit binary number that is represented as a b of n minus 1, dot, dot, dot. Suppose
Okay.
b
Now, like we discussed about 1's complement, 2's complement, similarly for decimal number system, its counterpart is 9's complement and 10's complement.
binary number.
Now suppose, tell me any digit from 0 to 9, anything you want, 0 to 9, any number,
Represented as a
any one number,
gray number. I have
कोई भी number in between 0 to 9.
b of n, right? That is
Or choose any number between 0 to 9.
5.
5.
6.
Let us take 5 first. Okay. So, suppose this is called as the number n, so n is equal to 5. So, to find 9's complement of 5, what we need to do? How we is to find 1's complement? We are subtracting 1 from that number. Similarly here, you need to subtract 5 from 9. So what will the result? 4. So 9's complement of 5 is 4. Similarly, what will be the 9's complement of 6? What will the 9's complement of 6? कितना होगा? 9's complement of 6? So 9's 3. 9's complement of 7?
2.
It will be 2. Okay. Now what happens? The self-complementing code is a code if code word of 9's complement of n, code word of 9's complement of n can be obtained from the code word of n by interchanging all the zeros with 1. Okay, so let us see that. Let us take first example. Okay, this example is your XS3. Okay, let us verify. 5 means this combination, 4 means this combination. Okay, now if we interchange zeros with 1, can you get this code? Verify. देखो ये होगा. Is it only zeros ones are interchanged in these numbers? Yes or no? This one
Yes, sir.
interchanged, this one interchanged, this one interchanged, this one interchanged. At the same time, check it in this BCD code. Can you get it? They are not interchanged.
No, sir.
They are not interchanged. It will also not happen in gray code. So this will happen only in XS3. Okay. You can check for other combinations also. Suppose next example, 6 3. 6 3 means 6 is this, 3 is this. So you can check it is interchanged only, 0 is interchanged to 1 only, and 1 is interchanged to 0. This is interchanged, this is interchanged, interchanged. Okay. So this is called as the self-complementing code. Next set of code is called as numeric code and alphanumeric code. So numeric code which represents the only the numeric information, means numbers. So whatever we discussed, everything represents numbers only. 8421, gray code, XS3 code. So all are the numeric code. Next is alphanumeric code. So alphanumeric code represents both the alphanumeric information. So they represents the numbers also and also the alphabets, also the all the words. So these are called as ASCII and ABCD IC code. So this two code is called as a alphanumeric code. So short questions are only possible out of this. Okay, so keep that in mind. So we're not able to finish this, so we'll do that in the next class, error detection and correcting codes. Okay, so another thing, I will share you a slide of this. Up to this I already shared. Okay, next this logic gate slide I will share. You have already gone through that in your previous classes. Okay, in your +2 maybe, and also maybe in your 10th standard also. So go through this. So we will not take much time regarding this gates. Okay, so if you go through once, we will easily be able to finish this. If any doubt, then only we'll discuss. Otherwise, we'll go to the next part. Okay. So everyone write your roll numbers in the chat box. Write your full roll numbers.
So similarly, student, can you tell me how to obtain the z of a minus 2b?
So those who have mentioned, they can leave the meeting.
z of a minus 2 कैसे obtain करोगे? Performing the XOR operations of the previous bit. So previous bit क्या है? z of a minus 1, right? XOR of this corresponding binary bit, that is the z of a minus 1. Also got it? So dot. So similarly, you can calculate the ASC gain code, that is the Z0. So Z0 will be, tell me, what is the Z0? What is the Z0?